Okay, hello everybody. I'm Sudha Jamthe, and we are here at our weekly Wednesday. And this is the fun part of the week for me when I get to see my students past and present, and some of the speakers come back. And we have a live, interactive, nice Q&A. So if you've been here before, you know the drill. Let's use the chat here uh, and type away your comments and questions and get it as interactive as possible. Sneha could not join us, so I'm hosting this again this week. So I'm just going to field questions because we have a speaker who's very open for a nice open Q&A, and we don't have any slides or anything else. And I love this speaker for his career pivot as much as the experience he's bringing in robot testing that he's going to be talking about today. Okay, so without further ado, let me introduce you to our speaker. Um, Hello, German.
Hey, good morning. How are you guys?
Good. So this is German Matchniff, and he had actually come and spoken to my class. I think the business of self-driving car course, one of the very first ones on the AV side that I taught at Stanford Continuing Studies. And I believe at that time German was working on testing in Tesla, and the Model 3 had not gone out, and there was a lot of speculation. And so I remember it was exciting time. Uh, so my understanding of the whole what you call as testing is more than testing, because you're making sure that the equipment is ready and provisioned, and all the other process stuff that goes with it. And then you've had a nice career trajectory. You've been to Cruise, and now you're in Fetch Robotics. So let us get started. So the way we are going to do this, let us do some intros. And for everybody joining in, I apologize for the delay, because we tried out a new email system, and looks like it's in mail multiple emails, and some of you didn't get the Zoom. So uh, people are going to be coming in as we continue on. So we're going to do a round of introduction, but that's going to be part of the story, amazing story with German. Um, and then we will get into the details of what he's here to share with us about robot testing. Okay. And I like to keep this in the gallery view, so it feels like I'm talking to my class, because I miss talking to my class for real. So if you want to do it that way, otherwise we can pin it and we can talk to the speaker once you get started. Okay. So German, tell us a little bit about your background and where you got started, where you are.
All right. So, as hello everybody. My name is German Matchniff, just as I was introduced. Currently, I work at Fetch Robotics, doing most of the testing over here. But for me, started really back in 2016, 2017, when I had two choices, whether to go into the Navy or start teaching myself on how to do testing. And then I started off, obviously, that's when Tesla first became, they introduced the Model S, and it really started to, hit the ground running. So I wasn't really sure, but I was a big fan of Elon Musk, since for me, I'm like a big self-learner. So I was like, this will be a good company to work for with a visionary leader. So I started to go to Tesla and wait on their doorsteps to try to get an interview or do anything that I can to really like get my foot into the door. And
You were
finally,
a high school student, if I remember right. At that point, you were a high school student, right?
yeah, so I just graduated high school
Yeah.
at that time, and I wasn't really sure, like I said, whether to go to the Navy or like what my plan for my life was. So I was like, oh, but there's this new cool technology company, and obviously at that time, there still was prerequisites for other companies to have like a college degree, which I didn't have. I just had a high school degree. So the easiest way was to go, door to door, kind of knocking, trying to get my foot in the door. So
And when you say
finally,
you go and wait at Tesla, where do you go and wait to get to
just at the
attend
factory.
lunch?
I went to the factory. Yes, I would wait in front of the factory trying to ask a bunch of recruiters or anybody who'd walk in, be like, hey, you guys have any openings, anything? And for a while, there was nothing really there until somebody finally who was working for a contractor company came up to me and told me that, oh, yeah, we work, it's called Johnson Service Group. And they're like, oh, we have a position open in logistics, which is just basically, driving the cars, delivering them um, from point A to point B, getting them on a truck and then getting them ready to ship out. That was kind of my introduction to Tesla. And And I remember my first day working for the contractor. I did crash a couple of the cars because I was driving an Australian car. So I was not used to having a right-hand drive car. So I just like sideswiped a bunch of cars and I was like, oh my goodness, I just got in here. I'm about to get fired. But luckily that was not the case. It was just an accident. And then during this time, I lived in Livermore, so it wasn't exactly like there would be always traffic, and you know how Bay Area traffic is. Usually takes like hour to 90 minutes to get home. So a lot of times when I would get off work at like 3:34, I would stay at work or at Tesla for like 5, 6 hours teaching myself how to code because I knew that Tesla was more than just a car company; it was mostly software. So I wanted to get to learn more behind the scenes of that. So I started to teach myself how to code, and then through time, I got approached by people at Tesla saying, "Oh, we have internships, so you can come join the testing team or the Model 3 team through an internship." So I went internship at Tesla, and then before I knew it, I was working on testing the Model 3, and then I was there at Tesla for 2.5 years, 3 years before I did like little. What's that? I thought there was something, but no.
Yeah, it's fine. Please continue.
Yeah. But yeah, so I was there for 2.5, 3 years. Right before I left Tesla, right as the Model 3 launched. So as soon as it was introduced to the world, that's when I did like a little career change. I went to work for GM Cruise and did a bunch of testing and laser and radar detection on there. So mostly like process engineering, which was basically letting the car understand what it sees in the real world and beginning to, visualize trees, people, and create that difference for them. So that way, like for example, and learn traffic laws because it's a big thing for cars. Like we as humans know, like hey, like if it's a horse, a police horse, or things like that, like we know how to stop. But for a car, that's a whole new thing. Like it's a moving object. It could be a person, it could be a horse, it could be a child, and for a car, they don't know the difference.
That's the whole thing with the autonomous vehicles, and you stuck with the autonomous vehicle testing also, right? That's the
Yeah.
specialty. Yeah.
So one thing that's always been the same thing, it's always been autonomous. So whether it's with cars or now with robots, it's always been kind of trying to get as least of human interaction as possible and kind of help us, progress in that way to where um, they're not here to like really replace us, but they're more like to guide us and help us along our trajectory. Because as humans, we have so much capabilities and plans to just, especially doing now robots. Like you ever go to like Amazon fulfillment centers or any big warehouses, there's so much room to walk around, and it's impossible for a human to cover all that ground without feeling exhausted or tired. That's why there's such a big, job turnaround rate, like people quitting or leaving because it's just impossible as you get older. So that's why as we continue to grow, it's important for robots or autonomy to come in and take place and kind of, have the people, give them the pride and sense to work with these new up and coming inventions such as robots. And you could imagine like back in the day, like if you look at an assembly line, all those robots that are now, putting those car parts together and things like that. Those used to be people. And now we're like, as we're growing, it's you can build, 300,000 cars in a matter of weeks versus having it months or years.
And I have a question. I believe Tesla has those robotic robots, right? That make like KUKA robots that would do the assembly. So when
Yeah.
you,
So
yeah,
yeah. So Model 3 is pretty much fully automated except for like the M part of it.
yeah.
But other than that, the whole Model 3 line itself is like fully automated. There's very little human interaction. All you really have to do is just like, feed the parts. But other than that, like the car
Feed
puts
the
itself.
parts.
Yeah. Yeah.
Feed the robot was your job.
Yeah. Feed the
So
robot.
so tell me a little bit more about testing. Is there a difference in test? So you're at Fetch Robotics.
Yes.
Okay. I want to hear about that, but tell us a little bit about the difference in test. Is there a difference in testing when you start out with the AV, especially autonomous vehicles, and the robots? Are they all autonomous? Is there a difference?
So they're all autonomous. I think the main difference is just the scale of it. So for cars, the biggest test is kind of like safety for people. That's like the biggest thing we look out for, So I was working on a passive safety team and just kind of making sure that a person's safety is priority. Right now, because of Fetch, we're a startup. Obviously, safety is still very, very important. But right now, the main thing is kind of proof of concept and showing that the robot actually functions. So we know that going to warehouses, there's not as much human interaction as there would be going for a car example into the real world. split switched, because right now the main focus is kind of showing the proof of concept that the robot works, it's able to navigate, interact with people in a safety manner, but it's more, showing that you can go from A to B without having to worry about like, oh, the robot's gonna get lost, or you're not gonna have a babysitter, but somebody's gonna be in the car, always, whether it's driving it or being in the back seat. Whereas in a robot, there's nobody really sitting on it or watching it. It's more just kind of out on its own.
Yeah. I actually read some interesting research about how people interacted with robots, and they trust it when it looks cute, or they just assume the robot knows. There was this one research, I think, by Professor Ian Howard, where they followed the robot. They made people follow. They basically people followed the robot, and they kind of tricked it to send them to some kind of obscure place, and still people were following the robot, assuming in the fire that the robot knows what it is doing. So there's a lot of interesting dynamics out there, but I want to keep our focus on this testing part that you're working on. So first, tell me a little bit about Fetch Robotics. Just make sure, because we have people from international audience, just so you know, we have people from everywhere. We are talking about Silicon Valley and Rivermore, so I just wanted you to know we have Jose, who took my AV class. He's from he works on testing in the OEM parts life cycle he's joining from Mexico, and we have people from everywhere around the world. So let's keep it more global. Give us a little bit about what Fetch Robotics does to get us on the same page.
Okay, so Fetch Robotics is basically a cloud robotics platform that's specialized in like 3PLs and warehouses. So it's kind of like a fulfillment thing. So if you have any totes or big areas of service, whereas you have to like move a bunch of like customer products or consumer products and items that you have to feed a pipeline, or for example, like feed the robots for a car manufacturer, we will use our robots to basically deliver those parts, whether it be from like point A to B, to keep track of your inventory, to kind of
like
get an idea of where all your items are.
Is it like Kiva that Amazon has in their
yeah, basically, yeah.
But
it's like a warehouse managing robot, yeah.
But looks like the Fetch robot looks more like a robot, right? It looks big, and it's the Kiva.
So we have two different ones. So actually, the one that's like the most common picture with like little eyes, that's more of a research platform. So that's not actually sold to consumers. It's more sold as like a recruiting tool for universities. So basically, we will sell that robot to a university at a price, and then we'll kind of have them have fun with it. So whatever kind of raw implications that they can come up with the robot for picking or things like that. And we'll have competitions, and then we'll kind of use as a recruiting tool to get people to come and work for us.
Okay. And I saw something about robots disinfecting airports or disinfecting high schools now, post-COVID.
Yeah, so before, obviously, since this whole world, shut down, we had to kind of do like a little 360 or a 180 for us. So instead of focusing so largely on manufacturing, we took on sanitation. So as we took on sanitation, that's when we created a disinfection robot. So we have two types. We have one that's with builder robots, and that sprays out a disinfectant. And then we have one with Piedmont that does a UV light. So basically, either way, you don't need to have anybody there. You can just it will just go into a conference room or a room or a school, and it will disinfect the room while you're not there. Same thing with airports. So while there's like low traffic, the robot will basically go walk around, drive around. And as it's doing that, it will just disinfect like the seats, the toilets, bathrooms, things like that. And so your people can always be safe, and you don't have to have people exposing themselves, out in the real world. We'll just have a robot go run a task, disinfect the whole airport, seats, lounges, anything that's like high traffic area. And that's why we deploy our robots. And same thing with schools. So when your students are not there, like as you have custodial duties, or you have people, your janitors, instead of having janitors, you come and you buy one of these robots, and they go and disinfect your school.
Okay. So that gives us a context on where we are. So it's warehouse robots, and it's the robots. I like what you said is feed the robots that makes the car, but
Yeah.
that's more sensational to go in that direction. So I want to come back to what does testing look like? And everybody, can you please mute, because I'm hearing somebody's sound here. So just be careful if and since now people have started coming in, we are talking about robot testing, and German had actually done testing and in cruise and Tesla in the past. That's what we were talking about, feeding the robot to make the car. So jump in with your comments and questions, and and make sure, because we have a international mix and a good community, so make sure to connect with each other. So chat away, questions and comments. And some of you might have seen Herman back in our Stanford class when we started with the self-driving car course. So this is your opportunity to know, what does robot testing look like, because he's doing more than engineering testing, right? There's a lot more customer compliance stuff. So we're going to delve into that next. So tell us what does the testing job look like?
Yeah, so for us, it's not just, like you said, it's not just engineering testing. So for me, I do both software and hardware tests. So basically, when I first got this job at Fetch, I started building the robots, because for me, I kind of like getting started from the ground up. So I like getting an understanding of how a robot, like from all the perspectives. So like putting it together myself with my hands. So then I understand how all the different parts for us work. So we have, the main board, which is like the brain. We have a computer, we have MCBs, we have encoders, we have lasers, we have cameras, and all those things, all work together on this robot. So obviously we have functional tests on the PCBs, so basically like the brains and the computers. So we have tests on that to make sure that everything works and there's like the right amount of gyro communication, things like that. There's also like a hardware rumble test, which basically goes over a mat for a duration of time, to where it kind of shakes loose any components that could come loose. So if there's any intermittent connections or anything that could fall off a robot, or let's say somebody didn't put a screw tight enough, we will find that during this time. There's also like speaker tests that we go through, battery tests. Obviously, we go through a 24-hour charge test, to where we completely discharge the batteries and then completely charge them up again. And that's where we get to know how good the batteries balance together. And then we also have accessories, obviously, for these robots. So you have like a cart connect, you have an HMI shelf, we have, like I said, the disinfection robots, you have these RFID robots that kind of read or can tell you where a location is in your warehouse. So you have to make sure all those components work separately from the robot. That way they're interchangeable. So let's say like if I send a robot out into the field and something goes wrong with your accessory, we can send a replacement part. So sometimes we have to just test the robot's accessory. There's also obviously testing on how it interacts with people. So if it's coming straight towards you and you can see you in its navigation path, will the robot move out of your way? Will it continue to drive towards you? There's also with the cameras, there's testing on how well it can see with lights, because sometimes lights will give you a false positive, and that will make it seem like there's an object hanging from the ceiling when there's not. So you have to make sure that you can cloud that out and put IR filters or whatever the case may be, or recalibrate the cameras. Obviously, our cameras are from Intel, which is, we don't really do too much of testing on it, because we trust that Intel, since it's a mass produced camera, they should have done in-house testing. But because there's some specifications that we need, since the robot is probably, I want to say like 6 inches off the ground to where the cameras are positioned, we have to make sure that the cameras itself are not positioned at a higher level. So we do an intrinsic calibration in-house, to where we know that when a robot is navigating and you can see ceiling or ceiling lights and things like that, that it won't just automatically freak out or stop because it thinks that, oh, there's a light ray or a sun ray, so I can't go there. So we have obviously we have a partner in Airbus, and they do planes and things. And obviously our robots may be in a hangar and there's a lot of sunlight and things like that could affect the robot on how it navigates. We have to take all that into account when we test it in-house and see how it reacts to light rays, how it reacts to bigger planes, forklifts, people, dogs, whatever else there may be. Let's see, you see there's a little question. Let's see what it says.
It's just, are you running an AI ML edge footprint in the actual robot as well, or is everything mostly in the cloud?
So most of it is on the cloud. So for us, we have Fetch Core, which is kind of like our proprietary system, to where once you get this robot, you'll have a 3-day support from us, and the robot will map out your real life warehouse. So basically everything, and obviously as the robot is navigating, and this is using the SICK laser and the cameras, it will get a whereabouts of the whole footprint. And actually, obviously this is all done in-house, and we don't use like any RViz or ROS topics from a third party, because they do not map it as accurate as our robots can. And that way, if certain things change in the warehouse, so let's say you have a chair or a forklift and it moves, because obviously if you do it in like a third party application, if that thing moves, the robot will freak out because the object that was once there is no longer there. It's the same thing as if you, that's why you have Google Maps, always upgrading, because as soon as like there's new buildings or new trees, things are changing, and then all of a sudden the car or the robot in this case won't know exactly where it is in the world. But for us, since we're using an in-house application, as soon as that object moves, the robot on the spot can replan and remap itself, saying, oh, this object that's no longer here has moved, so I can clear this path for myself. There's no longer like laser points, there's no longer camera data. So now I can use this path and navigate around it. And same thing, we calculate like how people are moving around us, because just how you have traffic and you have cars passing you on either side, you have people passing the robot in the front, back, side. So obviously you have to take that into account when we're going through like heavy traffic areas. So even though we're feeding robots on the line, there could still be QC or a manager or tours, for example, that people are seeing. And the robot has to be able to adapt to the situation instead of just being like freaking out and stopping on the spot. And obviously that's not a good look. And the main thing is to get people or manufacturers to save money, not to lose money because a robot's taking 30, 40 minutes to deliver a part. So it's always constantly upgrading the map and things like that.
So since you worked with self-driving cars and now you're working with robots, I would like to understand, is the way the robot works, because that is also autonomous. So does it have the same scan the environment, do some localization, and then path planning and control? Is that the same kind of sequence, or is there any difference?
It's pretty much very much the same. Obviously, like I said, the cars are on a bigger scale and they have the same thing of like obstacle avoidance, but at the same time, it's, for us, I think it's a lot more predictable on a robot, because we have so many different variations that change so fast. So our cameras are real live. So obviously, like similar to what you see in a Tesla, where it's recording 24/7. Same thing with our cameras, they're always recording. Same thing with the laser data. But taking that into account, on a car, you don't have encoders in your wheels. On our robots, we have encoders. So exactly, we know exactly how fast or how far a robot moves. So it's easier for it to like navigate and change the lane path at given like usually like less than 1.2 milliseconds. You'll know how to replan around an object or stop if it needs to. But obviously that also takes into account when you have an accessory on top, because the robot might be top heavy. So you'll have to like adjust to that. So like I said, it's pretty much very similar, a lot the same, but I think in a robot interaction, it's a little bit quicker than a car could interact, because it's just so much more agile in terms of how fast it can move. It can, and in car, I think the one difference is a car could reverse. Our robots can't really reverse, but they kind of have to, do a 360. But luckily, because they're so small and agile, they can just, hold one wheel and turn another way.
Yeah. So while we are trying to understand how the robot works, the functioning, there is a question on this whole, the point cloud that you will use. Are you able to read the question?
Yeah. Point clouds, do you also share about customers, or are you?
So it's about the point.
I can also talk, but like if you have any questions you want me to explain a little bit more, where is that coming from? Feel free
this
to
might
ask.
be easier if you just speak up, because I want to make sure that everybody hears the question. I don't want to be reading the whole thing just like that. So do you want to tell us what is your question, Nicholas?
Yeah, sure. It's a lot of questions, but first,
one question.
The point cloud is do you generate the point cloud when you're doing these kind of things as well?
Yeah, so we generate. So for us, we also have what do we call, like a robot position. So where if a robot ever gets mislocalized, it kind of knows where it should go. So we have robot position in a warehouse where it has to navigate to. And obviously those point clouds, we on a map, you won't see the generated data, you'll just see like the real life laser data. But if for whatever reason there is an incident as to whether, like we had recently, somebody gets like run over or X, Y, and Z, like something happens, then we can generate that, and we have historical data and back files to where we can see exactly like what could have happened at a set time. And obviously it's always 360 days always recorded, but as to, in terms of like life to life, or like for a customer point of view, they only see like the real life in terms of like when they're working on it.
And
No, I mean, sorry, but I mean, like the reason why I'm asking is because I think that might be, if you're not, sharing it with the customers, it might be underused opportunity, because most of these companies, even though it's new warehouses, but especially for old warehouses, they basically have no idea of, what is the location of that space. So they can actually be able to use that for other purposes, and you can help them doing that as well. But that's it. Yeah.
Okay.
Since you compared with the self-driving car, I'm kind of, still stuck in that same zone. So
Yeah.
it has similar kind of object recognition, the training algorithms, less complexity because it's not driving in the middle of traffic in the roads, but it does the same localization and the path planning. I understand that. But talk to us a little bit more about, you have this in a B2B setting, which means you have a specific customer, and then within that customer environment, it is learning. Now you might have a different customer altogether, and then you have to learn in that environment. What do you go through to make that happen? Is that like a general software in the AI brain of the robot that is catering to all kinds of customer situations? Or do you have to test once you say, okay, now we are going after this warehouse customer, specifically this particular customer, we need to do a scan and learn their environment? And what does your testing look like when you do the
So for us, we do a lot of, so for us, it's not really customer type testing. It's more general. So our robots can be used in warehouses, in schools, anywhere really, because that like I said, the mapping is done on the spot in real life. So it's never like we have a prerequisite map and then we just send a robot out there. So as soon as each robot gets its own basic map. So if I say I have robot number 1, once that robot reaches this location, it will start mapping the location itself. Okay. So that way, as soon as it gets comfortable with its environment, it'll know like, oh, I can go charge here, I can go pick up this here, I can do this and this here. It's not like, oh, I have this pre-made map of this location and then I'll just put my robot on this map and it will know where it is. It's more like the robot has to get comfortable around its environment, map itself, and then do that. Now you could have just one robot, and let's say you deploy 10 robots, right, to the same place. Now you only need one robot to map the location of the place, and then you can add the other 10 robots onto the same map, and they can all work just fine. But you need at least one of our robots to kind of predetermine all the locations and things like that. So for us, for example, like when we do in-house map testing or right before a release, we have, since things change, like I said, in warehouses, obviously here, tables, chairs, things move almost once or 3 times, once every 3 months. We usually have a robot go and run around the warehouse, remap the warehouse, and then we can add obviously the next batch of 10 robots onto the same map, and it's just a continuous remapping and relocalizing and things like that.
So looks like there's like some kind of clustering approach. Like in self-driving cars, we have spoken about this where, there's a version of the AV's brain, right? That it knows to the perception model, right? It has a certain version. And we spoke about how when different people are working, when they have the production version of the car testing, and then they have the next version forked off, and then the engineer starts building some feature set. And what does that look like for the test engineer, right? When they go drive around and take the car for a spin to make sure they test all the features. So in your case, for the robot, it looks like it's a cluster of robots which have the same map. for a specific location. And then once they have that, so how do you manage that process? Is just pure version control, or is there like more, is it as complex as I'm thinking it is?
Not necessarily. I mean, so far, let's kind of to break it down. We kind of build our robots in a batch of 10. So let's say you have usually 10 robots at a time. And the easiest way to do this is, in a best case scenario, you want all of the different robots, so the cart connects, the X-rays, the disinfections, to all work together. So basically, you'll have, out of the 9 robots, you pick the first one that gets through the initial testing process. So it means like it gets through the torch test, the rumble test, the camera calibrations, all these tests. Now, once we put the skins on the robot, because obviously the robot has to cosmetically look good, now we'll send that one robot and warehouse, like map out the whole warehouse or school or whatever the case may be. And then you start annotating. So you annotate the map saying, hey, I have a conveyor here. Go pick up a tote here. I have a car connect here. I have some disinfecting spots here. So you map out and you annotate all that stuff. So most, like I said, that's why it takes usually like maybe 3 days of support. And we'll map out the whole area for you. We'll have like restricted zones, keep out zones, things like that. And once that is done, then we'll deploy the other robots onto the same map. And now they can all interact in different locations. You can have a bunch of different tasks you can do. Like you can have multiple robots. One can be picking up carts, one can be dropping off carts, one can be reading things like that, one can be disinfecting. You can all do it simultaneously on the same map. And so for example, like at Aero Electronics, I think we have 22 different robots that are all going in all across the, I think it's like 2-3 mile long warehouse. They're all just navigating at different spaces, different areas, just picking up things, dropping off things, going through a conveyor, dropping off a conveyor, and just all simultaneous. And obviously, as the robot is navigating, it's updating in real time, like, oh, this might not be here anymore. Let's update this location. This might not be here. And they're obviously all communicating on it through each other on Fetch Core, which is our map.
So earlier we had a question about what is on the edge. So, and you said you have a very strong cloud platform and Fetch Core. That's what.
Yeah, Fetch Core. Yeah.
So, is it industry standard that a lot of things are in the cloud, or is there, more? Do you have a more robust cloud platform, right? To help us understand
what. For us, the reason we're like the leaders in this is because we don't really have to do. So I don't know if it's like an industry standard. I just know that for Fetch, it just makes it a lot easier to where once we get into your house, you don't need to add like a bunch of extra, routers or things like that. All use our platform. So as soon as our robots land at your location, you don't have to do any changing to your warehouse. All you need to do is turn the robot on and then start mapping. Like that's it. That's as simple as it is. You don't have to add like any spots. Charging spot, this is this, and this. Like you can always change that, and we can just update it on the map, and that's it. Like, you don't have to, get extra routers or extra networks and start doing a bunch of changes to your warehouse to where, oh, the robot will only work if you have this, this, and this. Is like, no. All you have to do is have Wi-Fi, and our robots are good to go. No, you don't need a map up front, no. All you really need, like I said, like if I wanted to, like, let's say you're at home and you want a snack robot, like for example, a snack robot, all I have to do is send you the robot, it'll connect to your at-home Wi-Fi. So for us, let's say your Wi-Fi is, I don't know, Grandma likes robots, or just how you like phone connects to a Wi-Fi network. It'll just basically go around, map out this area, and that's it.
We covered a lot of mapping, getting started. So what do you typically do in the testing? Like, what does your testing components? Because you've mentioned testing of different parts, testing of connecting with the cloud, and then you spoke a little bit about the mapping in batches when it starts off. Did you have to create a whole testing plan for the robot? What are the pieces of?
So the testing plan is, we try to keep it as omnious and as open as possible, because the main thing for us is just kind of our software tests, they go through, obviously, like we have, like any places we have, like, for us, the main thing is we do a dog food dev, which is basically our people, our engineers, or our, like the little, like technicians, for example, like the people who work under me, will give them the, like a task. So let's say right before we deploy a fulfillment robot, we'll give you an opportunity to volunteer, because we want to, like, obviously for us, we want everybody at Fetch to feel like they're part of something. So we'll give them an opportunity to like enact as if they're like a assembler, for example. During this time, they'll use the robot, and then during that time, we'll know how many bugs we can encounter. So we'll have a completely random person who may never have, they know how to build a robot, but they never worked with the robot side by side. We'll give them like a test plan, be like, hey, we need 1 hour a week time, interact with the robot. So like give them a bag, give them this, and see how it interacts. And if you have any problems with it, like let us know or create a Jira ticket, and then we can kind of fix the issues in real time. So we kind of give people or customers a chance like that to kind of interact with it and give us our feedback. And so we have partners like Wargo, for example, and they have robots on their site, and they give us feedback almost daily or weekly, and we have like a meeting. Same with Billboard Robots, which is the one that's like in the schools, and they give us feedback, be like, hey, we didn't like how this robot did this, can you fix it? And usually we put an update out in like 24 hours or so, and we'll fix those issues to where those issues are always improving. Just because you can have like a standard test, but a lot of times like that's just from an engineer's perspective, and things can change so often. So I can say like, oh, test, make sure the robot works in this scenario, and there's LEDs here. And then all of a sudden, like they'll go in a completely different scenario, like in a school, and we'll go in the gym, and we're like, oh, we haven't tested this. Okay, let's figure it out. So for us, it's always a continuous improvement. It's not just, we have like a very steady plan of like, oh yeah, the accessories work, the robot works, okay, cool. That's it. But in reality, there's so many different aspects that could go wrong at any given time that we always got to be prepared to like have how other people see, interact with the robots and what could go wrong for them. Because some people may be afraid that like, oh, we need them to be happier. Like we had people who say that like, oh, we need them to be a different color or have smiley faces or things like that. And it's just like, well, you guys can add smiley faces or googly eyes, things like that. But, just comes down to how they see it. Medical. So we actually have.
Can we read the question back? So one want to make sure everybody can hear that.
Let me see. So the question, the one that I was looking at right now, it says, have you worked with any medical service robots? So we actually, if you ever guys heard of Diligent Robotics, they have one of our robots. That's our base. If you look at Diligent Robotics, their base is our robot. Let's see if I can.
Now I'll find it for you.
Yeah. Like again, using a research, yeah, that one. So it kind of looks like this. It has a top, but it's our base. So the navigation and everything is handled by us, but they added their own accessories. So they have like little eyes and face and arm. But that's basically what we use. Same thing with disinfection. So we don't actually make the tops for it just because as Fetch, we're not certified, or we don't want to be responsible for like the chemicals and things like that. We'll just give you like the base, so the navigation portion of it, as well as like the auxiliary interaction and IP addresses, things like that. But as far as like the accessory that you want to customize, that's all up to you.
So there's a whole ecosystem of partners that you have around here. With the car industry, you have certain compliance on what you're testing for, right? For the car to get out, there are standards. Mm-hmm. Do you have something like that for the robot? Is there some compliance standard or that you get certified for? What is that body? What does that look like?
Yeah, so we are just undergoing a lot of EU standards. So our robots are actually able to ship to Europe. But luckily, because our CEO is like one of the moguls, a lot of the standards that are made up for robotics actually start at Fetch. So most of them are, most of them are done here, and then they become like the standard for the rest of the world. So I know there's like, we just had a talk about it a couple of weeks ago from our CEO, and there's like a whole new handbook and guidance and things like that. And the whole initial print was done by Fetch. So we're kind of making the rules as we go.
No, but that's good because you're a market leader. You're kind of setting the standards. So anybody else comes in. Yeah. From a competitive standpoint, when somebody is comparing, other warehouse robot, then they have to kind of compare with what you have. There'll be some kind of feature set or safety standards or something like that, right? Yeah.
Yeah, exactly.
I think
Let me
Nicholas has more questions today.
So how do you create a boundary?
He's still on the mapping. He's
So we
excited
have-
about the mapping, right? Yeah.
Yeah. So for us, we can create a keep out zone, and it's as simple as like drag and drop. So you'll create like a dropout, and it'll be like a red box for the robot saying like, "Hey, don't enter here." As far as doors and things like that go, it can go through pretty narrow pathways. So if you look at the conference room, we have a little door here. Our robot can
Is it me or its connection?
Yeah, I'm hearing a break. Is everybody able to hear us?
without stopping.
Yeah, I have a problem now hearing
We
it.
are actually working with SIG
German,
to create an
German.
elevator by using
I think like
simple code
this,
to an
the
elevator.
sound is not coming through. It's lagging a bit. So maybe you can just turn off your camera. Sorry about that.
No,
Yeah, I think there was
one second.
you were cutting off in the middle.
All right, is this better? Can you hear?
Yeah, we can.
Yeah.
Yeah, thank you. So you'll have to repeat
Okay.
what you said. Yeah.
Oh yeah, so in terms of like, I think going back to the whole where the robot can know like where not to go, we have a simple thing such as like drag and drop to where you can create a boundary, and it will be called keep out zone, and that robot will know not to go near the keep out zone. And then similar as far as like elevators and things like that, we are working right now to integrate a trigger device where as soon as a robot gets close to an elevator or anything that's like triggered via like SIG TDC, things like that, it will open up the elevator. The robot can safely pass into the elevator and then go up to wherever it needs to go, and then open up the elevator again. And that's going to be all done through, Fetch Core as well.
So I have seen there are robots in the mall in San Jose. We have the Nightscope robot, and I've seen one in the airport where they all had names. I don't know what they had like person sounding names, but they're all like geofenced. So they go within that circle and then they kind of come back and charge themselves. So I'm guessing you don't have to geofence them because your customer location, whatever it is your boundary, right? They can go anywhere within that space, but you need to.
So the customer will create that boundary. So for example, like if I map out this conference room and I tell the robot like don't pass through the door, I think it usually stays like a meter or two away from that area just in case, unless there's like a really narrow pathway, then it will obviously navigate closer. But other than that, it will usually stay away from the keep out zones. And you can change them always. So like you can obviously publish your map or update your map whenever you need to. And then just instead of having a keep out zone, you can just make it like, it's like a green zone for us. It's basically like a robot okay to pass. And then it will just go through it.
Like
yeah.
In Roomba, we have a little thing, right, that stops it because it's actually looking for that signal and then it doesn't go past that room, right? But that's outside. So in your case, it's all in your cloud and it's all in its brain of the whole mapping. Looks like the customer can programmatically map that. Susanna has another question. I'm wondering how it can see human presence. It didn't enter when the elevator came because I was waiting. So, it is recognizing people as objects like the car, right?
Yeah, so a similar way, it will recognize a velocity of a foot. So as soon as you're moving your feet, it will kind of recognize that there's, so it can detect like, it will be like two little footprints basically. And it will detect like, oh, there's a human, as well as looking through the camera. We have a real sense camera on the bottom. It'll kind of see like, oh, there's a point cloud that looks like a person. And obviously as the point cloud becomes more and more clear, or the robot becomes more and more closer, they'll put the two and two together saying, oh, there's velocity of human feet and the point cloud or the object or the shadow looks like a person. Okay, maybe.
Okay. So I think, Susan, I hope that answered your question because she's looking at service robots in hospitals and there must be people.
It's still like a pretty new market for us. So we just, I think, Yeah, about 2 weeks ago or so, we had a meeting again with Wargo, and we're just now working on integrating the whole like SIG TDC to where we can trigger elevator opening, things like that. Just because they're one of the first customers that we had to have multiple floors to where they need the robots to be. And it's not just like a one floor operation where like most assembly lines, like if you go to Fremont factory, they have 2 floors, but it's not like too interconnected to where you can have multiple robots on 2 different floors and they will have its own map. But now with Vargo, they have to where they have to interact with both floors. So we're working on it now to where it can trigger that elevator door or conveyor or things like that.
So it is like it is mapping, but it's a 2-level elevated mapping. It's just a different kind of mapping for all purposes for your
Yeah,
system.
so right now the way they did it for the beginning consumers, like for Aero, for example, we split our robots. So we have 10 robots on floor 1, 10 robots on floor 2, and they kind of work like that. So you can have as many maps as you want. You can have like, I don't know, up to 20, 30, 40 maps and just have different robots everywhere. But we heard a lot of complaining or a lot of, it's easier to have just one map and make it all interactive and just have robots being able to, interact with elevators and things like that. So now we're working on improving it.
Yeah. Is there any other question? Because we have another 8 minutes and I want to make sure that I get your questions answered because I have some, but.
I have a question.
Yes, Jose.
On which platform are coded your solution, and do you use some links to open source platforms?
We don't use too much open source. The only thing we use open source for is like RViz and ROS. But ROS, even then, that's for like more research platforms. That's not really for customers. We use RViz and basic things like that. But a lot of it, once the robot, and that's most of it is done like through testing and things. But once the robot goes out, yeah, RViz, ROS, yeah. But once it goes out into the real world, it's mostly used on our cloud base, which is the Fetch core. So we don't really have any, yeah. The only time we would access that data would be if there's an incident, and obviously that's just like obviously using like RViz and things like that. But as far as ROS and topic things like that go, it's mostly for research, and that's not a consumer base. It's more like I said, for research, so universities, things like that. And for us, that's pretty much open source. So when it goes to a customer, we lock all the bootloaders and we don't keep it open source. But as soon as they order a research platform, then we don't lock anything. It's pretty much open and you can kind of mess around with the robot as you wish. But obviously have safety deals in place and things like that.
Okay, thank you.
So I want to come back to, how you kind of navigated your career to get this, because most of our students here are interested in, moving to the AV space. And, we talk about, business models or data or computer vision. From what you were talking about, you casually said, yes, we all obviously go and do the mapping and navigate it, but we also go and do annotation. So looks like you are cutting across a variety of different roles, right? You're calling it testing. The kind of things you're doing, you're actually doing some computer vision annotations, you're doing some kind of, getting your cloud system, and you said you unpack and pack and assemble the whole robot. So if somebody wants to get started and do testing in the robot world and do something closer to your field, or if you're hiring people or you're going to scale or something like that, what does it take to get started? Seem to know a lot more than the average test person, right? You're a test analyst, right?
Yeah, so it's hard to say what it would take. I think the easiest thing is just having the aptitude to kind of go out and learn for yourself, such as like, because ROS and things like that, like anything you go into robotics world, like ROS is just out there. If you go out on Google or just start looking into ROS and like working with like Arduino and things like that, and like trying to debug things and understanding how all those systems work together with each other, that would be the easiest step. Because for me, like I got lucky because I'm working hands-on. So when I came into this world, like I knew about testing in terms of cars and things like that, but that's because I worked at like Pet Boys and I understood cars itself. but robotics was like a whole new world to me where I didn't really know anything. And for me, I'm like a very hands-on person, and I like having a challenge and learning things on my own. And once I got here, I started to figure out how all the different components of a robot work together with each other and how they can, you know, kind of make it better for the world and make it better for me and how they can interact.
Yeah. So you have picked an area. You said you were excited about, how Elon Musk was a visionary, and you went to Tesla, and you started from there, and that's kind of put you on this whole AV world, right? The autonomous world, I would say, right?
Yeah.
What do you see yourself doing next? Because you're constantly learning, and I believe you're going to college too, right? Because when you started out, you were a high school student.
Yeah, so I'm learning right now. So Mission College offered a course in like ROS and things like that. So I wanted to kind of get the basics down. Because for me, I understand how things work, but I don't know like necessarily the right vocabulary or dictionary for it, or like the base for it. Like I know coding, but I don't know how to, for example, like what certain things or how to say it or how to get there. I just know how to get there, but I won't know how to describe it to somebody else and be like, oh, this is how you open a terminal. This is what you have to do. So I'm trying to get like the basics down. But for me, as far as the next steps, I think I'd love to become more of like start my own thing in terms of like consulting other, in terms of anything with AVs or automotive or automation. That's kind of like the next step for me, is just because I like, because I know a lot of people, especially my friends, like they're still afraid, like, oh, they're coming to take my job, or they're doing this, this, and this. In reality, the situation is the world is changing, and we have so much opportunity as human to like be part of something that's hasn't been done before, but we're too afraid to like kind of take that step forward. And a lot of us are in the same boat. Like for me, like there's no way I should ever be, you know, in leading charge in the robotics, because I don't have a single degree to be here. But it's more like, you just kind of have to take the step, and things are changing around you. At the end of the day, it's a good opportunity to show your grandkids or your kids or anybody like, hey, I'm working with robots. Like not many people can say that. You've seen Wall-E, and it's how it goes.
Yeah.
Exactly.
So I have a question talking about robots. It's nice to see you're very humble, saying, you don't have the robotics degree, but you're doing this. But I appreciate how you've kind of self-taught and built yourself, right? So what you know from your experience and how much you do in terms of, interacting with customers and taking care of everything that needs to be done. You're more a operational person, right? So who brings a combination of the operations plus the engineering in there, right? So I think that's a unique skill. I don't think they can get anybody with another degree who's just going to be able to replace that. So I think you're safe there. But it's inspiring, especially I'm always thinking about my students, my future students who are thinking about career pivoting and learning new things, because that's kind of our common theme in everything that we do here. So we hear a lot about automation replacing jobs. So I'm happy to hear that you're saying that, they're doing the jobs that the humans should not be doing, which is unsafe for them in warehouses or impossible because of the scale, physical labor needed, right? And you're also giving hope that anybody can come in and learn it if they have your kind of grit, right? Which is not common, but I appreciate that. But I see in manufacturing especially, there's a lot of augmentation, right? There are these robotic arms that work with people, or there are robots who are in an assembly line working with people. Do you see that as a norm that is happening, to where it is going to be robots working with people? And do you think your robots can learn to collaborate with people in some sense, or is that something totally different?
No, I definitely can see it. Just walk down just so I can kind of show around. Like you
Yeah,
see
yeah, would love to see it. Thank you.
have all these robots. It's definitely, they're working closer and closer to, kind of grow. Like we had one of our research platforms, they're kind of learning to like make drawings and kind of work hand in hand. Now obviously that's going to come with a lot of like studying and, kind of interacting how people interact with that. Because if you make like sudden movements and things like that, obviously it's just like a person, you won't really like somebody coming at you really fast.
Yeah.
The same thing with robots.
So can we see your robot up close? I know you showed.
Yeah, 1 second.
Yeah.
Let me just open up the light here as I can. So it's kind of quiet. All right. Oh, it looks like it froze on me for a second here.
Yeah.
Let's see. We can, okay, awesome.
Yeah, I can see you well.
So basically, we have all these different ones. So this is the Car Connect robot. As I was saying, there's the cameras, there's the laser.
Yeah.
And basically, this will kind of go up and pick up a cart.
Yeah.
We have roller tops. So these work with going to like conveyors, things like that. We have shelves to where you can put like your packages. You just throw them on here and it will go and drop them off. And then we have these research ones, which I was saying. And these are the ones that have little faces. And
Oh, this is the one that you said they are more cute ones that we see outside. Yeah.
the little faces.
Yeah, I remember seeing this. Yeah. Yeah, in your
Yeah,
video.
and then we have the tag surveyor, and that's this one. And then basically you have this different locations and read the tags and kind of give you an idea of where a certain object is. And you
Yeah.
have like RFID tags on there. And then these are the little ones. And this is the one that gets
We lost your voice for a minute, so you might want to repeat. You said these are the little ones.
yeah, so these are the ones that go into the airport.
Cases? Está en el mochila. Oh,
Are there other people there?
Let's see.
Yeah. Yeah, I didn't catch the detail about the little one. What is special about the little one?
So those are the ones we send them out to the airports, and that's the ones that they add the accessory on. So they'll get like the disinfection and things like that.
Yeah, yeah. This is
So
amazing.
they're pretty open.
Yeah,
All you really need is all you need is just Ethernet connection and auxiliary
Yeah.
power. And then
that's amazing. That's amazing. This is fantastic stuff. Thank you so much. This was beautiful. We appreciate you coming, taking the time to talk to the class and answer all these questions so candidly. So we should
Of
wrap up with that. Thank you so much. And we've got the recording, so the recording will go up on Weekly Wednesday, where people signed up from. So thank you, everybody. Thank you, Herman. And we'll be in touch
Sure.
and we'll be cheering for you as you do bigger and better things. Thank you so much.
of course, thank you.
Okay, bye, everybody.
Thank you. Bye.
And
Take care. Bye-bye.
yeah, people in the cold belt, please, especially those who are facing the storm and the power outages, please stay safe.